Okay, let's start a new project here. I'll do File, New Project, and I want XNA Game Studio 4.0 there, and just Windows Game. And here, main thing we'll be eventually looking at is collisions. So let me just call it collisions, and I'll click OK. Okay, so I saved off some pictures, and let me bring up Paint.net to show you what I've got. And I'll do File Open, and saved off this monster, that monster, and what else did I save off? This rock and this snake. Okay, let's open it up. Okay, we're going to start off the snake. Now, this isn't a great picture for a game because we're going to check collision based upon the corners of this, and you got a lot of white space here. So what we want to do is we want to make it as small as possible for the white space, like that right there. So I click the rectangle select here and select it, and I'm going to do an edit copy, and I'll do edit paste into new image. Okay. I'm not going to spend a huge amount of time making this look good. That's not my goal here. I want to choose the appropriate pink to make it transparency. And I really thought that there was one of these that did that. But anyway, it should be 255, 0, 255. So let me come over here and change the RGB colors to that. And I'll choose my paint bucket. Now click in here in this. Oh, that's actually not too bad. Okay. Now I'm going to save this. So I'll do a file save. And I'm in my pictures there, PNG. I'll just call it snake.png. And then I'll click OK there. And let's come over to our game here. And for the collisions content over here, I'll right click on there and I'll say add existing item. And I'll come over here and choose pictures, and I want to choose snake. Now by default, if I click this, again your asset name should be snake, and it is, so that's good. I'll come over here and underneath the graphics device manager graphics bright batch, I'm going to type in texture 2D and snake 1. I also want to have a rectangle goes along with it, and I'll call this rect snake 1. Now we're going to come back to that. Let's come down here to our load content, and I'll go to the end of this to do. Press enter, and let me see. Snake 1 equals to content dot load texture 2D, and then I'll put in snake. Now this snake you see right here, this corresponds to your asset name. So if I click here, your asset name here should be the same as that. The rectangle. Forget what I called it. Okay, rect snake 1 dot width is going to equal to snake 1 dot width. So the width of the rectangle is going to equal to the width of the image. So this is my image. That's what I called my image, and that's its width. We're going to modify that, but we'll start with that. And then our rect snake 1 dot height is equal to snake 1 dot height. And rect snake 1 dot x will equal to 0, and rect snake dot y is going to equal to 100. Let's say 100. Okay, and then we'll come down here to our draw section, and I'll put this after the to do. I'll say sprite batch dot begin I don't remember if I need to print these or not. I think I do. And then sprite batch dot draw, and then it's asked me for the texture 2D. So snake 1, comma, the rectangle that goes along with the snake 1, comma, color dot white. Now, if you use color dot white, it's full color with no tinting. And then sprite batch end with parentheses. Okay. Well, let's draw this, or let's run it. So I'll click the little green arrow up there, or choose debug. Of course, Avast didn't like it, as usual. Okay. I really should change Avast to allow it, but I never have taken the time to figure out where to do that at. Okay, continue execution. There's our snake. Obviously, that's too big, isn't it? So what I can do is up here, instead of it making the width of the rectangle same as the width of the snake, I can do a divide by 2. And this one I'll do a divide by 2. That'll make it half as big. Let's see what that looks like size-wise. Yeah, that's about what I wanted. Okay, now what we want our snake to do is we want it to move across the screen through each game cycle. So I'm going to come down here to the update section. And I'm going to say the rect snake1.x is equal to rect snake1.x plus 1. What this will do is it'll take the old value of the x component of our rectangle, add 1 to it, and then store it back into the x. So it'll increase it by 1 each time. Let's see what this does. So you see our snake's going across the screen. Now again, we could change that such that it's plus 2 if we want the snake to go faster. That's a little bit slow, but let's see what happens when it reaches the end. It just keeps going forever, so it goes off of our screen. What we want it to do is when it reaches the other side, we want it to go back. So what we need to do is we're going to create a variable up here. And we've been using, you could think of these as variables. Technically they're not. But we're going to have a variable, int right. And what this is going to keep track of is this will keep track of the right side of our screen. We're also going to have a direction. And what should I make this? String snake 1 direction. And initially, the snake 1's going to be going right. Let me just make R to be a little bit simpler there. Okay, snake 1 direction. Now, int, that's a number with no decimals. And we'll set this here in a minute. But that's going to keep track of the right side of our screen. Now, this snake 1 direction here, equal to R, string is, you can put anything into it. You can put letters, numbers, weird characters, anything. Now I call it snake direction 1. You call this whatever you want. Your brain has pieces of information that stores all throughout. Like your phone number. If I ask you what your phone number is, you probably can tell me. Well, that's stored in your brain, and that's like a storage location. And that's what a variable is. It's storing this off so the program can access it. Well, let's first take a look at the right. And we're going to put left here also, so we'll come back to that. I'm going to come down to right here. And I'm going to say right equals to graphics.graphicsdevice.viewport.width. So that's going to the width of the screen, let's say it's 800 pixels. Right will contain 800 once that gets done running. Okay. So down here, I'm going to change this, the update logic. I'm going to say if snake 1 direction is equal. I might have to do a dot. Equals. And then I'm going to put in R. Then I'm going to move it, increase the x by 1. Else, I'm going to take my rectsnake1.x equals to rectsnake1.x minus 1. Okay. Well, if the snake1 direction, that's my string, that's my variable, if that's equal to r, and that's what that dot equals checks, if it's equal to r, that means I'm going to increase x by 1. If it's not equal to r, then that means it's going left. So what I need to check in here is, has my snake went past the right-hand side of the screen. So I'm going to say if rectsnake1.x is greater than right. Then I want to change snake1 direction to equal L. I want to go left. So R means it goes right, L means it goes left. Let's see how this goes now. So let me run it. Should have increased that by 2 so it goes a little faster, so I don't have to wait. And not working. Oh, there it went. Oh, I know why. When I got an image, got my snake here. So I got my snake image. The upper left-hand corner is our X and our Y we're referring to. This corner over here would be our X plus the width of our image. And then Y. So what I really need to check is I need to check the X plus the width. Okay, so coming down here, I got snake1.x plus. Now the width is kind of tricky, because what I did here is I took the original one and divide by 2. So I haven't changed the actual size of the image, I just changed the size of the rectangle. So down here, I want to check the there it is, the rectangle. So this, the X plus the width. I'm going to put parentheses around the X plus the width. If you're not very sure what the order of operations is, which one it's going to do first, then put parentheses around it. I know that this is going to take my X value and add the width, which is what I did over here. Here's X, then this corner here is X plus the width. So let's run this now. Still didn't change it to 2. Painfully slow. Okay. Hits that, bounces back. Okay. So let me change these to 2, or change it to 3 so it's a little faster. Like that. Much better. Hits that and then bounces back the other way. Now when it reaches the left-hand side, look what happens. Keeps going forever. So we need to program that in. Well, left side's a lot easier. I wouldn't even need to put a variable for it, but I'm going to. Now when you got variables, you can declare them together like that. You can do a right, comma, left. Or you can put them in separate lines. I could do int right, semicolon, and then int left, semicolon. Semicolon ends the line. And down here, where I told what right is, I'm going to say left is equal to 0. Come down here. Okay, so this is controlling whether we're going right or we're going left. An if-else statement says if this is true, then you do this. Else, you do this. Okay, so here we're checking to see if it's gone past the right-hand side. So now we need to check if it's the rectangle snake1.x, and I don't need that extra parentheses. Rectsnake1.x is less than 0. Well, if it's less than 0, that means it's going left. That means we want to change our snake direction to equal to R. So it'll go back right. So let's run this. Okay, comes over here, hits the side of the screen, bounces back, goes like that, hits that, bounces back. So it'll keep on going back and forth till the game ends. Okay. And it takes a little bit of getting used to. You have to think through the logic and so forth, but try to use the things that pretty well self-document. R means go right, L means go left. If this has gone past the right-hand side of the screen, we want it to go back left. If this has gone off the... Why did I put 0 there? Left. There we go. If it's gone off the left side of the screen, then we want to go back right. Okay, so that's one snake. Well, we want another snake on our screen. Now, we can use the same image. We do not have to re-import the snake as a different name, but we need a different rectangle. So up here, under our rectangle, I can do a comma here, or I could put it on a separate line. It doesn't matter, and have its own. Doesn't make any more efficient one way or the other. So I'll choose a second rectangle. Now, this is the snake one direction. I'm going to need a snake one or snake two. Sorry, I'm distracted. What I'm distracted by is that little green squiggly underneath my left. What's that mean? Is never used. I thought I used it down below here. Yeah, I used left. I assigned it up here. It could be it just hasn't updated because I changed that, and sometimes it doesn't actually, until you run it, realize that. But again, a little green squiggly tells you maybe you declared a variable but you didn't use it. Okay, so we got our direction of snake 2. Well, down here, I'm going to basically copy these lines. So I'll save myself some work here. Again, usually I type these in to get down. Like that. And then I'm going to change all these 1s to 2s. There we go. Now, instead of this being at 100, I wanted it maybe at 200. And this, I'm going to put it over at the right side of the screen. Now, if I do a right like that, my image should be off the screen. So I'm going to do a minus rect snake2 dot width. Now, I think that'll work. Sometimes I have to play with it a little bit to get it. And why doesn't it like that? I'm assuming that's okay. It's probably just need to run it. Sometimes the little red squiggly is correct, sometimes not. Oh, this should refer to my... That's my image name. That's not my name of my rectangle. Sorry about that. Okay. Now I come down here, and I want to draw my snake. So it's spritebash.draw snake 2. Rect snake 2 dot color dot white. Well, let's see if I have it right. And obviously I don't. Now I say no here, and you see it says snake 2. I can double click this. It'll go to where my error is. Why doesn't it like snake 2? Oh, because we're using the same image. I'm just putting it in 2 different rectangles. Okay, it just hasn't updated. Let me run it. Well, that one's working fine, but my other one's gone. Okay, what's wrong with it? Oh, I haven't checked any of my directions here. So I need to copy this code. So I'm kind of a little bit worried it didn't appear on my screen at least, but we'll come back to that. Okay, this is I'm going to put comments in here because I'm starting to get too much. This is snake 1 movement. Snake 1 movement. And this one is going to be snake 2 movement. Okay, so if snake 2 direction is equal to R, then we got this. And then change every one of these snake 1s to snake 2. You can imagine this would be real tedious if you had 1,000 snakes on your screen. But we'll see how to handle that with arrays later on. Right now we're just doing this tedious wise. Okay, now let's see if I have more programming problems. Well, that's not good. I didn't want them to be going like that. I wanted the snake 2 to be going to the left to begin with. Let me see. Okay, snake 2 direction is equal to left. And let me get rid of that width there. Okay, so that should appear equals right. But look where I loaded right at. Down here. Doesn't make any sense to use right before you declare it, before you assign it. So let me move this. I'm going to do a cut on those, and I'll paste them up here. Like that. Okay, now let's see. There, that's what I wanted, but it's off the screen. So down here where it says right, I want to either add or subtract the width of the rectangle. But I think it's minus. Sometimes I just have to play with it and see. Part of programming is the fun of it is, you know, doing things like that and trying to figure it. That looks good. Okay, so going off like that, going to bounce back. Okay, so now we got our snakes going across the screen. Okay, what we want is our main character. Let me get rid of that snake. Yeah, this was one. This will be our main character. I want to have this move across the screen, and if it touches any of the snakes, then I want something to happen. That'll be a collision. Well, this picture's too big, and I can go ahead and resize it here if I want, but I want to paste in my pink. There, that'll make it transparent. Yeah, let me go ahead and change image size. I'll resize it to see what 100 looks like width-wise. And where's my mouse? There it is. Okay. Yeah, that's okay. So let me do a file, save as, and I want to change this to a PNG. And Monster 2 is okay, I guess. Actually, let me call it main for main character. So main PNG. And click save. And click OK. Okay, so let's come over to our game, and we want to right click over here in the content, choose add existing item, and I want to choose my main. Now again the asset name will be main. You can close that error list if you had an error. I'll come up here and have a new texture 2D. And I'll call it main. Keep everything simple. I need a rectangle. I could declare it on a separate line, or I can just do a comma and say rect main, like that. And come down here. Want to load it in. So this is be my main character. Sometimes you put these documentation just so you can easily see where things are. So say main is equal to content dot load texture 2D main. And I need to work with my rectangle. So I'm going to say my rect main dot width is equal to the width of the image. I'll say rect main dot height is equal to the width or the height of the height of the image. And my rect main dot x is equal to 0, and rect main dot y is equal to 500. That should throw it down at the bottom somewhere. Now I want to come down here to the draw, and I want to draw it. Okay, so we got sprite bash dot draw main rect main dot color dot white, and let's run it. I've either thrown my character down too far, or I've got something set up wrong. Let's see. 200. Let me set it at 300 and see. I had it down too far. Okay. Now what I want to do is I want to program the arrow keys so that I move my character on the screen. So I'm going to come up here into my update section, wherever that's at. Oh, down. Okay, come down to my update section, and I'm going to document this. Main character movement. Okay, so let's see, keyboard state KB equals keyboard dot get state. And I'll say if KB dot is key down keys dot right arrow, or the right. Then I want to move my rectangle for my character. So rect main dot x is equal to rect main dot x plus 1. I'm going to have it move a little bit slower than my snake's going across the screen. If KB dot is key down keys dot left, then rect main dot y is equal to rect main. Okay, rect main dot x is equal to rect main dot x minus 1. Okay, if KB dot is key down, this is again checking to see if they pressed a key down. Keys dot up, then rect main dot y is equal to rect main dot y minus 1. And last one, if KB dot is key down, keys dot down, and rect main dot y is equal to rect main dot y plus 1. Well, let's see if it works. This is the incremental approach to development. You got an idea of what you want to develop, and you get it piece by piece working. So I got my snakes working first. Now let me see, my right arrow key, that's working. Left arrow key, that's working. Down arrow, that's working. Up arrow, that's working. Now as I move this up, and it collides with one of these, let's see what happens. Nothing. Nothing happens. So let's program into collision now. So I'm going to come up here, and this will be in our update. There it is. This is in the update section. And I'm going to say check for collision with snake 1. Now I'm going to say if, then beginning parentheses. When you have an if statement, whatever your condition is, you have to put inside of parentheses. And I'm going to say main rect main dot, and there's an intersects, and I do intersects beginning parentheses, and I'll say rect snake 1. Then that means that my character intersected with the rectangle of snake 1. And I can do a this.exit, the end of game. Let me come over here, and I'm going to check for collision with Snake 2. So I'm going to say frect main, oops, wrong one, main.intersects, then the rectangle of Snake 2. This.exit. Now, I can't stand how slow my character is moving, so let me change this to 4. Typically in a game, you want your character to move faster than the monsters. Because if the monsters move faster than you, the game's over almost immediately. So, let me run this. Okay, so we got our character moving around here. If I move it up here, when that snake comes back, it should intersect. And our game's over. Now, let's look at our original characters. Yeah, we have white space up here that isn't part of the actual creature, but it's part of the rectangle. The problem with this is if I run this, if I move it up, try it again. Okay, move it up. Right there. Move a little bit more. Right there, my snake would not actually hit my head. But see how the game ended? That's because we're checking the different rectangles. If I open let's see, recent snake. If this particular corner here, do the paintbrush. If this particular corner right here touched, like this corner right here, then that would tell me, or that would tell the game that they intersected. So if you want to, there's different ways you can do collision. Sometimes you have to attack it from a different standpoint, and we'll see that with an example. But just your basic intersects like that, you have that problem. So again, you try to make these as small as possible. Don't have any extra space. Make this rectangle as small as can be. We can do a Control Z and Control Z again to get rid of those. There we go. Not that I wasn't going to save them, but okay, don't save. Don't save that. Okay, we got another creature here, and I'll resize them. You can resize them in the game. You know, you can make them whatever size you want, but you know, might as well make them the size you want over there. If I come here under the properties window, if you don't see properties window, again, you right click on the image, you choose properties. You see the content processor. There's different items you can set here. You can change some of the color key combinations. See the RGB. See, yeah, that's 255, 0255. That probably seems familiar. Resize the power of 2. That more 3D game. I really thought there was somewhere you could set the size of it. I don't see the size here. Forget that then. The memory's no good. Texture, format, color. Oh well. Let's take a look at this other creature. And I'm going to resize it to 200. That's still pretty big, isn't it? Image, resize it to 100. Okay, and now I'm going to zoom it. So up here, click the plus to zoom it. And then, where'd my pink go to? Because my pink's gone. So 255, 0, 255. Choose my paint bucket. And paint that, and paint that, and paint that. I still got a little bit white down there. Let's see if I can, good enough to click it. Good enough. There was a little bit white there, and I could tweak this to get it a little bit better, but who cares? We're just learning. And I'll do File Save As. monster 1, and I'll call this a PNG. Then save. And then click OK. Now I'll put this somewhere on my screen. And so let's go over here. We're going to right click on the collisions content. Choose add existing item. And I want to choose my monster1.png. I need to come up here. I need another texture 2D. And so I'll just come up here, do a comma. Monster1. I need a rectangle. So I'll come behind one of these, put a comma, rect, monster1. Now, he's not going to move, or she, as the case may be. And this is our monster1. So monster1 equals to content dot load texture 2D, then monster1. You'll get very used to doing this, such as this kind of comes natural. Rect monster1 dot width is equal just the width of the image. You can also hard code values here. I could hard code 100. Let me show that. And rect monster1 dot height is equal to 100. Then rect monster dot x is equal to 200, and rect monster dot y is equal to 300. So again, we looked at taking the width, and you divide the width of your image by 2 to change that. We looked at just setting it straight to equal to that, or you can hard code a value. Now you have to be careful here. The 100 by 100 makes that a square. It originally wasn't a square. It was like 100 by 93 or something like that. Well, let me come down here and draw it. So I got spritebash.draw monster1 dot rect monster1 dot color. Let me change this to pink or yellow. And then run this. Now, see the take a look at the color of my image here compared to the color is on the screen. See what changing the tint did? So you can get that to change it. You could actually change your tint, you know, on every game cycle. Now, when I say game cycle, what it's going to do is, let me close this. Up here at the top, the initialize, that's run one time when the game runs. Load content is run one time when the game runs. Unload content is run one time when the game ends. Update, this is this is through a game cycle, so it continually runs update over and over. How long is there between game cycles? Well, when one game cycle finishes, then it just goes through the process. So sometimes you have to be careful about this, because if you got a machine that's has a faster processor, it'll go through these game cycles faster. So it may affect your results differently. Okay. Now we want to do a collision checking on this. So let's talk more about our new monster. Okay, so we're going to have our image of our good guy, our character, like this, and this is our main character. This corner here is XY. This corner here is X plus the width. If I could spell. Try it again. X plus width, and then comma Y. This one down here is x and then y plus the height. And this one, this corner down here, is x plus the width, y plus the height. Now, it really is kind of a pain to define your own collision. It's much easier just to use the intersect, and especially at the very beginning. Now, here's our monster. So here's our monster. And, monster. Back to grade 2, learn how to spell monster, wherever grade that is. Okay, there we go. Now this is our xy of that rectangle. And this, just like this one over here, is x plus our width, comma y. And this one down here is x and then y plus the height. And then this one here is x plus the width, comma, y plus the height. So same idea as this. Well, if I'm programming my own collision, here's Happy Face coming along, our main character, and he's going to collide with our monster. Well, that means that this corner here is greater than this x value, and then we have to see about the y value also. So you have to program that. So we're going to take a look at programming this. So let's come over here. So check for collision with monster 1. Okay. Now these take a little bit of thought process, and sometimes I don't get them right the first time. First thing we're going to check is the upper left-hand corner. This corner right here. So we have to worry about this. So we're going to check to see if the rect main dot x is greater than monster 1 dot x. Oops. Dot x. Okay. Well, what that means is that this x value, this corner, let me draw it. Okay. Okay, so if we're programming this is our main character. And we're looking at this corner right here. So we're saying it's greater than x. So here's x. Well, greater than x could be this right here. Because this is my main. This is greater than x. So we not only need to check to make sure it's greater than x, it has to be greater than x and less than x plus the width. So over here, I want to put an and in here. And let's see if I can remember this. I think it's and like that. Rect main dot x is less than monster 1 dot x plus monster, or I don't want this to be monster 1. I want it to be rect. Rect monster 1 dot x. And rect main is less than rect monster 1 dot x plus rect monster 1 dot width. Okay, that's one part. And I know that's a little bit confusing, so if that throws you, for now, just stick with the intersect method. This is when you want to program something a little bit special. You want your own collision taken into account. Okay. Well, that handles it okay. That means that check for my collision that this point right here has to be greater than this and less than x plus width. Fine. That would handle that. But what if my picture looked like this? Here's my my corner I'm looking at. Well, it's definitely, here's your x value, and here's your x plus width. It's definitely greater than this and less than this, but it's not intersecting the picture, is it? So we need to also check the y value. This would be our y, and this one is our y plus our height. I know you can't read that, but so I'm going to do a check here. I'm going to say if rect main dot x dot y, sorry, is greater than rect monster1 dot y, and rect main dot y is less than rect main or rect monster dot y plus rect monster1 dot height. Well, that means they collided, so I'll say this dot exit and end the game. Okay, well, let me run that now. Let's see, we're going to check that one corner now. I have to very quickly get on the other side. Okay, so I'm over here. Now the upper left-hand corner of whatever this creature is what I'm checking. So I'm going to move a little bit closer and see how it intersected it. And what was my monster? So okay, look like that. It may actually even be easier if you had a instead of making this transparency to begin with, to make it a certain color. So let's do that actually. Let me change this to black. And then save that. Now I'm going to come over to my game. And I come over to my content here in my monster 1. I can right click on it and say click delete. And it'll be deleted permanently, and that's fine. Now right click on this again and I'll say add existing item. And I'll bring the monster 1 in. Now, it shouldn't have changed any of your coding. So now if you run it, okay, our monster 1's on there, and it's in black. Now, unfortunately, we can't see the this, but if I move it a little bit closer here, maybe I ought to go and change the color of my creature there. Move a little bit closer. See how it intersects? And I know you can't see that real well, so that's water in here. Let me bring this creature up here, and I'll make the surrounding whatever that color is. There we go. File save. Okay. And I'll come over here to our main, right click on it, choose delete. And I'm going to re-add it back in. So right click on content, say add existing item, and choose main. Okay, now we'll be able to see the collision a little bit better. Boy, that color's not very good. Now my background is light blue, isn't it? Let me come over here. Scroll down to the bottom. You see up at the top here, down in the draw section, it says graphics device clear color cornflower blue. Let me come here after the color and do a dot and change it to tomato. This will be the color of your background. Okay, that's better. I can see it better. So come over here, bring my character down here. I'm looking at my upper left-hand corner of my image, so I'm getting closer and closer. See how it intersected? So that's working. That side's working. Well, we got 4 other corners. Now they're going to be very similar to this. So I'm going to copy this, paste it down. That's the upper left-hand corner. or upper right hand corner is x plus width and y. So that's the upper right. So I'm going to change this to rect main.x plus the width. So rect main dot width. And over here, this will be plus rect main dot width. And do I need to change the y values at all? No, this is still just y here, so we're fine there. So this, let me keep track of this. This is upper left corner. This one is going to be the upper right corner. If nothing else from this, taking this class, you'll get a better idea of why they have flaws in games, because there's so many little things you have to think about. Okay, so I'm getting closer and closer, and see how it intersected? So that's working. Okay. Let me now program the lower left corner. So lower left corner. Okay, lower left corner. Well, we're now looking at lower left corner is right here. So we got x and then y plus the height. So I come over here. The x is okay, but then down here for our rect main dot y, we want to say plus rect main dot y, or wait a minute, dot height. So we're adding the height to the y. In this one, we got rect main dot y plus the rect main dot height. There we go. And that's the lower left corner. While I'm at it, let me go ahead and program the lower right corner. Excuse me. Very tedious to program the intersections yourself here. Now for our lower right corner, that'll be this one right here. And the x is going to be x plus width, and the y is going to be y plus height. So we'll come here, and here's an x, so that's going to be plus rect main dot width. This rect main dot x here, it'll be plus the width. And this one, the y, will be plus the rect main dot height. And this y will be plus the height. Okay. Now let's run it and see how our different collisions work. So lower left and lower right. So I come up here. Okay, I'm going to go, and that one worked. That was lower right, so let's look at the lower left. Actually, I can go off the screen here. I haven't programmed that such that it doesn't let me. Okay, and there it worked. So our collision's working. You can the same thing that Microsoft programs in there for you for intersect, we just did by checking the corners. Again, why is this important? Well, now you can modify this to do your checking. Like if I put my cursor right here, you can't see this in YouTube because it's so small, but the lower right hand corner tells you where you're at pixel wise. So I could come down here and I could program in. Let me actually draw squares on here so you see what in the world I'm talking about. And again, you could get real extensive with your programming on this. This right here, I could program in to be a. Let's try it again. Why is my? Okay, I'll make that 2. Okay, come down here. This right here, I could program in as a dead area, such that if this intersects something, that particular piece right there, then it's not going to end the game. I could program in this piece to be a dead area. I could program in this this rectangle right here to be a dead area. I could program in this piece. And I could program in this piece. So even though my image contains all of those, I could program these in. And if I spend enough time doing this, and the same concept we just did, where we're checking this, this, and this, and this, you could set it up to check these. Like when I drew this rectangle here, it starts, of course, in my upper left-hand corner, which is 0, 0. If I put my cursor over it by right here, it says 23, 0. So the width of this rectangle is 23. So this would be x plus 23. If I put my cursor down here, that now says 23, 48. So the height is 48. So again, you could program this in exquisite detail to get it precise. Now I'm not going to actually program this one. I just want to talk about it. This may be what we'll do in the next lesson on this. Is we'll try to program the game Asteroids. Now, I think it's called Asteroids. It's where you got little meteors going around the screen. Maybe it's called Meteors. I don't know. I think it's Asteroids. And they're going off the screen and appearing on the other side and so forth. Definitely an asteroid meteor is circular in pattern. Well, exactly in the middle here, the size of my image is 225 by 225. So if I take 225 divided by 2, wrong one. I think it's 112.5. Yeah, go away, Adobe Captivate. I don't want you. Brought you up by accident. Okay. Okay, so we got 225 divided by 2. Gives us 112.5. So for our asteroid here, the width and height of this are both 225. Our exact center, this would be the point, 112.5 and 112.5. Now rectangles do not give you the option of putting decimals in there. So with 113 and 113. Now there's another way of doing decimals, which we'll look at later on. But that's our exact center. Okay, so let's go back to our image. And right there. Now, assuming that this is circular, I can come out here to the outer edge, and this says approximately, let's say 200. So 200. Okay, so we got this is 113, and this would be 200, and this is the shape of our meteor or asteroid. Well, the radius of this would be 200 minus 113, which would be 87. So R is equal to 87. So when I want to program this in, maybe if I have another circular pattern coming in, I'm going to have to worry about more than just corners, because these don't have corners, do they? And like I say, we're not going to worry about that now, but this is just an example where you have to do a lot more thought process on collisions. If you got a bullet playing Call of Duty, and here's your character. Should have been an artist. Got our character like this. We shoot a bullet. Well, if we go with our strict rectangle like this, a bullet passes through here, it kills our character because we're doing an intersection based upon the rectangle. If it hits here, it shouldn't kill our character. The only time it should kill our character is when it gets close enough to this. Now, different packages do this different ways. Some of them allow you to define circles. Circle here, you have a circle here, and some of them you define squares. And now, unfortunately, XNA doesn't have all that kind of capability. You have to kind of really work hard at it. It only gives you intersect for that. But anyway, that's our game. Now, this is basically how they can develop Frogger. You know, you have things going across the screen. Now, I have them bouncing off the screen, but you could have them appearing on the other side. So let's look at that as our last thing in this particular game. So we're going to add another snake on there, but instead of it bouncing, we're just going to have it wrap around, appear on the other side. Okay, I'm going to use the same snake image, so I don't need to have another snake, but I need another rectangle. So we're going to have rect snake 3. Direction of it doesn't matter. I'm just going to have it always moving to the right. Down here, I want to have another rectangle for that snake, and so I'm going to copy this. Change these all to 3s. Oops, that should be just snake. That's referring to the image. This is a rectangle. Okay, 3 like that. Now the X position. I'm happy with 0 like that. And this one will be up here at 0, 0. And then down here in our movement, again, if you put the comments there, it makes it very easy to find your code later on. Snake 3 movement. You can have extra lines in there. It doesn't care. And I'm going to say rect snake 3 dot x equals rect snake 3 dot x plus 4. It'll move a little bit faster. Let's draw that down here. So I'll say sprite bash dot draw snake 1. We're using the same image. Then rect snake 3 dot color dot light blue. Let's see what that does to our snake. Looks a little darker, doesn't it? So again, change the tint. Now, I went off the side of the screen and just disappeared completely. Well, that's not what we want. I'm going to come up here, and we're going to check to see if snake 3 has gone off the screen. Now, let's talk about that. This right side here is in the variable called right. And here's our snake. When our snake has gone completely off the screen is when its XY position, the upper left-hand corner, is past this. So we're saying where X is greater than right. Okay, so that's where we're going to program in. So we'll say if, and you have to have parentheses around it. So rect snake 3 dot X is greater than right. It's gone off the screen, which means I'm going to set my rect snake 3 dot X equal to 0. Now this is going to cause us a problem, and you'll see why. So let me run that. Okay, so it's gone off the screen. Boom, it just appears, doesn't it? What we want it to appear is we want it to appear like it's coming off the side of the screen. So instead of setting it equal to 0, we want to say 0 minus I think the width of the snake. So let's see what that does. 0 is, of course, the left side, and I guess actually, since I declared a variable called left, I ought to use it. So left minus the width of the snake. So there's our snake going off screen. And now see how it comes from the left side as if it, a little bit at a time. So that's the way we want for scrolling. Now this is again how they program in Frogger. You just have things going across the screen like that. You can throw some randomness in there, which we'll look at later on. Now they do not program in. I hope they didn't. 70 different creatures going across the screen, or however many is on Frogger. Using arrays, you can save so much code. Using procedures and functions that we'll see later on in the course, you can save a lot of code. But for now, it's just kind of clunky. And that's the end of that game. So let me go ahead and save that.